this question, we have some tree diagrams. So Sue either travels by bus or walks when she visits the shops. The probability that she catches the bus to the shops is 0.4, as we filled in on the diagram. The probability that she catches the bus from the shops is 0.7. So all of this has been filled in correctly. And for part B, we want to show that the probability that Sue walks at least one way is 0.72. Well, to do that, we've got two options. You can either work out the probability that she walks and look at every option. So that is that she takes a bus to the shops but then walks home, or that she walks to the shops and then takes a bus home, or excuse me, or that she walks to the shops and walks home. So everything that involves walking in some way. So we can work out that probability by doing this. So we can say probability walks at least one way. This is probably the harder way of doing it, but it is a bit more straightforward. It just takes a bit more writing. So the probability that walks at least one way, that's the probability that she takes the bus to the shops. So bus to and walks from. So that's this first branch, or this first pair of branches, if you like. Or she walks to and takes the bus from. So that's this one. Or walks to and walks from. So there's three possibilities. We can calculate the probability of each using the and or rules. So and means times. So the probability that she takes the bus to the shops and walks from the shops is going to be 0.4 times 0.3. So I've got 0.4 times 0.3, and means times. Now or means plus. So to factor in the second possibility, I add. So I've got or walks to and takes the bus from. Well, that's going to be 0.6 times 0.7. And then remember, I have or, so that's plus again, walks to and walks from. So that's 0.6 times 0.3, and means times. So that gives me, right, 0.4 times 0.3 is going to be 0.12. 0.6 times 0.7 is 0.42, and 0.6 times 0.3 is 0.18. If I add those up, so 0.42, 0.18, 0.12, if I add all those up, 12, 7, I get 0.72, which is what they wanted us to show. A slightly easier way, so I would say, let me just get more space here. Or we can work out the probability. So this is called using the complement of the event. We can work out the probability that none of these are true, that instead she takes the bus to and from the shops, and I'll show you why we're doing that now. So we can work out probability she takes the bus to and from, but then you work out the complement of this, which is just 1 minus. If you work out 1 minus the probability that she takes the bus to and from the shops, I'll just highlight that in red. If we work out 1 minus this probability, we should get the probability that we had before, because it's the probability that she doesn't take the bus to and from the shops. And this is a much easier method, really, because the probability that she takes the bus to and from the shops is going to be So let me just do 1 minus and then the probability we want. So the probability that takes the bus to and from, well, the probability that she takes the bus to the shops is 0.4. Then I've got that and means times. The probability that she takes the bus from the shops is 0.7. So I've got 1 minus 0.4 times 0.7. 0.4 times 0.7 is 0.28. 1 minus 0.28, 0.72. It's much easier. It's one line as opposed to several lines. So hopefully that makes sense, and I really would like you to give that a go on Maths Watch if you haven't filled that part in. So question 2. So Ben and Tom each take a driving test. The probability that Ben and Tom will pass is 0.8 and 0.7 respectively. Complete the tree diagram. Work out the probability that both will pass their driving test. Well, there's only one possibility there, and that's Ben passes and Tom passes. So A is very straightforward. I want the probability that Ben passes and Tom passes. Well, I can put my numbers in now. So the probability that Ben passes is 0.8, and means times. The probability that Tom passes is 0.7. So I'm looking at doing 0.8 times 0.7, which is just 0.56, because 8 times 7 is 56. So that's B. And then C, work out the probability that only one of them will pass the driving test. Well, let's have a look at the possibilities we could have. We could have Ben passes and Tom fails. Or we could have Ben fails and Tom passes. There were no other possibilities. So I would say here that we would need to do, because I don't really think that using the complement here would be too helpful, because you're just doing the same amount of work really. So we say probability of Ben, so I'll use B for Ben passing and Tom failing, or Tom fails, or Ben fails and Tom passes. So that's going to be, just putting the numbers in, 0.8 times 0.3 plus 0.2 times 0.7. Just following the branches. 0.8 times 0.3. 0.2 times 0.7. Let's calculate these. So we have 0.24 plus 0.14, which will give us 0.38. I will just check that briefly. Actually, no, I'll do that later, but that's fine. So hopefully that makes sense. And if you've got any more problems, please let me know.